I want to do a visual proof of the sum and difference identity, so I'm going to run through a way to do this. And some of these things you just kind of have somebody sit down and played with enough till it made sense. But once I get you set up, you should be able to take this and kind of run with it. So I'm going to start off with just a line down here. And we're going to create an angle. We're going to call it A. All right. And I'm going to make a right triangle out of angle A. And I want to add another one to it and call that B. Because I want to figure out what happens when I add angle A and B. So here's angle A plus B, and I'm going to just kind of complete a little square around the whole thing here. And I want to work it out where this is intentionally a right triangle, that's a right triangle, and there's some other right angles going on in here as well. And I also want to intentionally make this be 1. So that's the setup. This will be a good way to visualize the proof if you use that setup. So in class, I'm going to have everyone do it in class, but if you're doing this at home virtually, this will be the point where we want to stop and start filling in whatever you can. You should, ultimately, we need to get the sides filled out for this, and that will give us our proof. But fill in as many pieces inside as you need to get all that. And you'll definitely want to start inside. And the fact that this is 1, you really probably want to start with this big triangle using angle B for the beginning. All right, so hopefully you had some luck here. I'm going to go ahead and do a walkthrough. And again, as you're going through this, if you need kind of a nudge or a hint, pause it. You get a lot more out of this if you do it yourself. So pause it and then kind of take it and run with it, and then kind of catch back up, see if what you're doing matches what I'm doing here. So again, I'm going to start with the angle around B because I got this side being 1. So what I do know is the hypotenuse is 1. So if I do sine, then sine of B would be this side over 1. So this would be sine of B for sure right here. By similar logic, cosine of B would be this side over 1. So if I call this x, if I call this x, cosine of B would be x over 1. So just this side is cosine of B. Now that I've got that done, I'm going to move on to this angle, or this triangle down here. It's also a right triangle, so sine and cosine are definitely going to work. And I'll just kind of make up some x's as I go and use this as a workspace. So if I call that x, then sine of A would be x over cosine of B. So x would be sine A times cosine of B. By similar logic, if I call that x, then the cosine of A would be x over cosine of B. So this side down here would be cosine A times cosine B. And the next place I would move into would be looking at this triangle right here. So a good way to figure this angle out, if this is A, this has to be 90 minus A. Because these two are complementary. There's 180 degrees in the triangle. Here's 90 of them. These two have to split the other 90. So if you think about how this is going to work out, if this is a complement to A, these two have to add to 90, since this is already a right triangle, this piece has to also be A right there. Which means this piece has to be 90 minus A, which may or may not be that important, but I'll go ahead and fill it in. Now because that stuff's true, the sine, if I call this piece x, the sine of A would have to equal x over sine of B. So this side right here has got to be sine A times sine B. Now sort of similar logic, if I call this piece right here x, this side, then the cosine of A would have to be x over sine of B. So this side right here is sine B times cosine A, or cosine A times sine B, however you want to go. I'm going to put sine first for a reason, but either way is fine. All right, now I really want to get this angle right here. By the same kind of logic as we figured this out, if this is B, and this is a right triangle, this is 90 minus B. And then if these three are going to have to add to 180, then 180 equals this piece I don't know, plus 90 minus B plus 90 minus A. So working out what I got, this is 180. I can subtract those 90s off. And that means 0 equals x minus b minus a. So I could add the a's and the b's on both sides. So that angle right there has to be a plus b. And there's probably lots of other geometric ways to get there, but that has to be true. That piece has to be a plus b. Now that's a plus b, and I want to find out what this side is. Let's call it x for the time being. The sine of a plus b would have to be x over 1. So this side over here has to be sine a plus b, which is good because that's one of my formulas I want to figure out. And by a pretty similar logic here, if this is called x, then the cosine of a plus b would have to be x over 1, adjacent over hypotenuse. So this piece right here has to be cosine of a plus b. Now that I've got all the edges figured out, this is really where your proof happens. So sine of a plus b, which is one thing I was trying to prove, has to be these two pieces added together. So sine a cosine b plus sine b cosine a. I'll put it in a little box to make it stand out. The cosine one's a little trickier to see, but cosine a plus b plus this side has to equal this side. So another way to think about it is this long piece minus this shorter one has to equal what's left here. So cosine of a plus b would have to equal this entire thing, cosine a cosine b, minus this little piece up here, which is sine a sine b. So that's the easiest way to prove this that I know of. And you could do a little bit of similar logic here, but I'm not going to go through all the proof of it. Here's where the plus and minus comes in. Whatever sign is here, you have the same sign there. So if this is a plus sign, this is a plus. If this is a minus, that's a minus. Again, you can create a diagram, prove it that way, but it checks out, I promise. Now whatever's here, this is the opposite. So if this is a minus, this one's going to be a plus. And that's where that minus over plus sign is going to come in. That's kind of a weird symbol, but that's what it means.